Hey everyone, welcome to The Explainer. I am absolutely thrilled you're here. Today we're tackling something that affects literally every single one of us who deals with complex technical information. We are talking about the architecture of scientific paragraphs. Now, I want you to think about drafting a dense scientific paper kind of like engineering a building. You wouldn't just, dump a massive pile of bricks on a vacant lot and expect it to magically hold up a roof. You need a blueprint. You need real structure. Because when we're dealing with inherently dense material, the stakes for how we structure our writing are incredibly high. So today, we're going to sketch out those blueprints together, and we'll look at exactly how to engineer text that stands strong.
So, have you ever been reading a super dense academic paper and suddenly you have to stop, reread a section like 3 times, and you're just left wondering how on earth you ended up on a completely different topic? The source text we're analyzing today describes that exact feeling so perfectly. It says the bad structure causes a kind of mental whiplash. It leaves the reader totally lost, wondering if they missed a connection or just misunderstood the entire premise. Our goal with this explainer today is to cure that mental whiplash completely. We want to make your complex material as effortlessly clear to the reader as possible.
All right, let's start right at the beginning with the absolute basic building block of our blueprint, the paragraph. By definition, a paragraph is just a unit of logical organization introducing and treating a single idea. That's it. Every single time you see a paragraph break, that little indentation or a line space, it's actually a visual signal to your reader. It announces the appearance of a brand new idea, or at the very least, a totally new perspective on something you've already been talking about. It's basically a clear marker in the journey of your overall argument.
Okay, let's dive into this. Here is the roadmap for our explainer today. We're going to start with the anatomy of scientific paragraphs. Then we'll hit the 3 critical pillars: unity, coherence, and distinctness. And finally, we'll wrap it all up with building the bigger picture.
Starting off with Section 1, Anatomy of Scientific Paragraphs, and specifically, we're looking at the power positions.
Now, as readers, we inherently look to specific places in a text for the most important information. We definitely don't give every sentence equal weight. The human brain naturally pays the absolute most attention to the first sentence and the last sentence of a paragraph. Those are your power positions. The first sentence gives you the roadmap, and the last sentence delivers that punchy take-home message. That first power position is exactly where we place the topic sentence. In scientific writing, your topic sentence should almost always be the very first sentence. It announces the destination right up front. The key thing to remember here is that it declares the central idea, but it doesn't need to over-explain every single tiny detail right out of the gate. The science is usually way too complex for that anyway. Instead, it just sets the route. It tells the reader, hey, here's exactly where we are going, which prevents any nasty surprises and guarantees a much smoother ride to the finish line.
Let's move on to our first major pillar, Section 2, Unity. One core idea.
Unity is basically the foundation of our building, and it dictates one very strict rule. Absolutely every sentence in a paragraph must relate back to the core idea declared in that topic sentence. No exceptions, no wandering off into the weeds. This slide brilliantly illustrates what happens when unity breaks down. Let's do a little live editing here together. On the left side, we have this paragraph about protostar accretion. The topic sentence promises to discuss 2 main forces, gravity and radiation pressure. But if you look halfway down that left column, suddenly there's this random sentence stating that electromagnetic forces drive stellar winds. Wait, what? A third force? And then, right at the very end, it starts talking about heavy elements. If you're reading this, you are definitely getting that mental whiplash we talked about. You start wondering, wait, did I misunderstand the topic? Now, look over at the right side. We've deleted those jarring, stray sentences about stellar winds and heavy elements. And what's left is a structurally sound, highly unified paragraph. Every single sentence on the right directly develops the relationship between gravity and radiation pressure. It passes the unity test with flying colors.
All right, so how does this build into our second pillar, Section 3, Coherence, and creating logical flow?
If unity is the foundation, coherence is the framing of our building. Once you have unified sentences that all belong to the same idea, coherence is about how those sentences interlock perfectly to actually support the reader's understanding. They have to be presented in a logical, step-by-step order. What's really fascinating about this slide is that standard organizational schemes aren't just arbitrary writing rules made up by grammar nerds. They literally match how human beings naturally organize their own thinking. If you use a scheme like spatial or temporal, let's say describing an experiment from beginning to end, you save the reader massive amounts of mental energy. They don't have to scramble to figure out how to organize the data in their heads because, well, you've already done the framing for them. Whether you're moving from general to specific in an introduction or simple to complex when explaining a new model, using a recognizable scheme makes the science immediately accessible.
Another completely crucial part of coherence is parallel construction. Take a look at this enzyme assay example. Do you notice the pattern here? We purified, we added, we incubated, we assayed. It uses the exact same sentence structure, the exact same tense, and the exact same voice for every single step. Now, inexperienced writers sometimes think they need to constantly mix up their sentence structure just to sound interesting. Actually, scratch that. In technical writing, too much variety really disrupts coherence. By using this parallel construction, your reader isn't forced to stop and decode brand new grammar with every sentence. They just effortlessly absorb the scientific procedure.
Coherence also relies heavily on transitional expressions. Think of these as the glue holding our frame together. Take a look at the left side here, the 1998 lava paragraph. It really just lists facts. The lava was richer in metals, it was denser, ejective volumes were similar. It feels incredibly choppy, right? Like a robot just reading out data points. You're forcing the reader to guess how all these separate facts relate to each other. But now, look at the right side. By adding really simple relational devices like furthermore, despite these differences, and as a result, the entire text transforms. It flows so smoothly. The writer is doing the heavy lifting of connecting the ideas, creating a perfectly coherent logical flow.
And that brings us to our third pillar, Section 4, distinctness, or self-contained thoughts.
So think of distinctness as the exterior walls of our structure. A unified and coherent paragraph also has to be self-contained. Now, this doesn't mean it exists in a vacuum. It takes the reader onto a new track, for sure, but it's a new track on the exact same journey. It has to stand completely alone while still pushing the larger argument forward. Distinctness is often compromised by what the source text calls link failures. Let's just quickly fire off these 3 common pitfalls. First up, superfluous paragraph breaks. This is when a writer thinks a paragraph is just looking a bit too long visually, so they just hit enter without actually shifting to a new topic. Second, over-strong dependencies, which we'll look at in just a second. And third, redundant paragraphs, basically repeating the exact same topic in multiple places, which just creates text bloat and really confuses the reader.
So the absolutely crucial point here is how to avoid that second pitfall, overstrong dependencies. This happens when you start a new paragraph with a phrase like, despite this, or because of that. The reader starts the new paragraph, but they're entirely dependent on the previous one to remember what this or that even means. You fix this easily by naming both halves of the linkage. Don't just start with despite this. Instead say, despite the difference in the replicate experiments. Just briefly repeat the antecedent. It creates this solid bridge between paragraphs without ever compromising the distinct, self-contained nature of the new one.
Finally, Section 5, building the bigger picture and assembling our sections. Let's zoom out for a second. We've just engineered these perfect, unified, coherent, distinct blocks of text. Now, how do we assemble them into larger sections of a manuscript? Well, all the rules we just discussed apply on a macro level too. One of the single most powerful tools in a science writer's toolkit is consistency in paragraph order. Think about it. If you present 3 hypotheses in your introduction in a specific order, say A, then B, then C, you should absolutely mirror that exact same paragraph order in your methods, your results, and your discussion sections. By doing this, you're taking full advantage of established reader expectations. You create a massive shortcut for their comprehension because they already know the rhythm and the structure of your argument.
Which brings us to our final slide, and really the ultimate question you have to ask yourself. Are your paragraphs actually guiding your readers, or are they giving them mental whiplash? By mastering this architecture, by ensuring every single paragraph has unity, coherence, and distinctness, you stop forcing your readers to constantly decode your structure. Instead, you allow them to just simply marvel at your science. You have the power to engineer incredibly clear, captivating technical text. I really hope these blueprints gave you a solid foundation to take back to your own writing. Thanks so much for joining me on this explainer, and keep building great things.